Hello, my name is Adam and this is Rockstar Math Productions.
Okay, today we're going to be using inverse operations and adding and subtracting to solve for basically algebraic equations. And this is kind of a departure from the old elementary-ish principles of, kind of putting your answer off to the side. Obviously the kids know that, x equals 3. But what I want to really focus on today is using inverse operations and getting students to work down, show their work below the problems by rebalancing. This really comes in handy when we get into multi-step equations later. But here the focus is going to be on identifying, obviously here's the variable and here's a constant we want to get rid of. And we're going to use the inverse operation, which is subtracting 12 from both sides, and then you have x equals 3. And this applies to problems even when you have the variable on the other side of the equation. In this case, you want to get y alone, so you add 8 and add 8, and then you got 18 equals y. And it's so funny, a lot of my students, even in a problem like this, will say y equals 18, but I really want them to focus on keeping things on the side of the equation that they're on and working with it right there. We're really going to be also using these balance scales kind of as a metaphor, in that, here if you have, for example, 5 and 3 things together, you know that they're going to be 8. And so if you were to subtract 3 here, obviously it'll be unbalanced, so you have to do the same over here. So I'm really trying to use these models kind of as a way of trying to be a paradigm shift into solving algebraic expressions. So I actually do have some model scales we're going to be using to talk about that, and write kind of a little reflection at the end of class on how is an equation like a balance scale, and how does it equal various things. Two operations that undo by minus or plus. Another word of using inverse is opposite. 5 plus 2 is?
7.
How about 8 plus 1?
9.
Okay, here's a hard one. Ready?
6. 6 times 1.
The problem. What's the last term? Inverse operation. Tommy, did you come up with inverse operation? What do your notes say?
To undo.
Sorry?
Undo.
Undo? That's a great descriptor. What else?
It's called simplicity. What this is?
After you guys have 10 in each side, I want you to add 3 to one side only.
Okay, I do it.
Add 3 to one side only, Jacob. Okay. Okay, and here's what I'd like you to do. I want you should have 13 in one side, and you should have 10 in the other. I want you now to add a certain number of tiles so that it is now balanced again.
Go figure.
Side. Put M tiles in each side.
This M tiles, okay? No.
How's it going there, guys?
She says M seems like more.
Okay. How many is M?
More than 0, so it's more than 0.
Why can't it be 0? Could M be 0?
Because you said, I don't know, M, so estimated guess.
Couldn't I substitute 0 in for M?
Yes.
So as long as you have 0 on both sides, that would also be a possible solution. How many do you got in each side now? 4. How many do you got in each side? Okay. How many is M for you guys?
0.
Okay.
write the equation. Are you sure?
How much is the? Yeah, it's not.
You guys mind if I videotape over your shoulders here?
I might be wrong. I don't know.
I think it's 592 minus 300.
How's it going over here, guys?
6. Could you help me? This would be a negative, right?
Yep.
No
'cause
way!
That's the inverse to positive.
Negative 6. That means 6 minus 2, right?
That's negative 6 plus 2. So it's minus 4.
Oh. Negative 4.
What up?